Chapter 5, Section 8 is about applying special right triangles. So, by the end of this lesson, you should be able to justify and apply properties of 45, 45, 90 triangles, and do the same thing with 30, 60, 90 triangles. So we have two types of special triangles. They have a right angle in them, so that's where the 90 degrees comes from. And then the other special thing for this one is that both of these angles are congruent. So because angles have to add up to 180 degrees, that means both of them are 45 degrees. Now, because of this, we know that this length here and this length here have to be congruent because of one of our theorems that we learned back in Chapter 4. If these base angles are the same, the sides that make it up are the same. And then this takes it one step further. These sides are the same. Whatever they are, your hypotenuse is always the square root of 2 long. And we can prove this using this triangle here. So let's say we have a 45, 45, 90 triangle, and we know it's 45 because we took a square, and all of these squares would have 90-degree angles, but we cut it in half. So if we use the Pythagorean theorem, so then plug in what we have. I know one of the sides is x long, the other side is x long, and the hypotenuse is y long. If we combine x squared plus x squared, that's really like having 2x squareds. And then if I want to simplify this, since both of them have a square, I can take the square root. Whatever you do to one side, you got to do to the other. So this breaks up into the square root of 2 times the square root of x squared. And the square root of y squared is just y. Now this part right here will simplify into plain old x, but the square root of 2 can't. So this right here proved our theorem that before that says y is the same thing as x times the square root of 2. And this works for every 45, 45, 90 triangle. So these rules you need to remember. In a 45, 45, 90 triangle, your two base legs are congruent, and your hypotenuse is whatever that is times the square root of 2. So let's do an example. If I know that I have a right triangle from this, and one angle is 45, by the third angle theorem, I know this angle has to be 45. And then I know several things. I know if this is 8, that this also has to be 8. But in this case, I'm supposed to find x right here. So the relationship is whatever your sides are, your hypotenuse is that length times the square root of 2. So in this case, x equals 8 times the square root of 2. And you can just leave it like that. Now this one's a little backwards. This one tells us that we have a right triangle, and then it tells us that these two are congruent. So that means that these two angles are congruent, and because it's a right triangle, that means they both have to be 45 degrees. So you need to be able to recognize all of this stuff from just two pieces of information that they give you. They give you x and x. So because I know it's a 45, 45, 90 triangle, I can use our theorem that said our hypotenuse is whatever our sides are times the square root of 2. So the opposite of multiplying by the square root of 2 would be to divide by the square root of 2. So remember, we can't leave things with a square root in the denominator. You've got to put it in simplest radical form. So that means we have to rationalize the denominator. Hopefully you remembered that from the other night, which means turn this into something a little prettier. Square root of 2 times the square root of 2 is really the square root of 4. 5 times the square root of 2 we can just leave. But the whole reason we did this is so that I can get the square root of 4 to turn into a whole number. So that is how long both of those legs are. 5 root 2 over 2. So then we got another one. 30, 60, 90 triangles. And these ones are a little more complicated. But in a 30, 60, 90, you again have one right angle. But instead of these two being congruent, one's 30, one is 60. That opens us up to having 3 different side lengths. This is a scalene triangle. So your shortest side, we'll call it S, is related to your hypotenuse and your longer leg. The short side to the hypotenuse is an easy relationship. It's just twice as big. So like if this was 5, this would be 10. Your longer leg has a little weirder relationship. It's whatever your shorter one is times the square root of 3. So again, if the shorter one was 5, this would be 5 times the square root of 3. And again, we can prove this. If I give you, first off, a triangle that is equilateral, that means it's equal angular, 60, 60, 60. But then I cut it in half. So this cutting it in half with a perpendicular bisector gives us 2 triangles. Gives us a 30, 60, 90. So I know this one's 30 because it's half of this one over here. So then we can quickly see if all of our sides were the same length here, all of these were 2x, this was 2x, this whole thing had to be 2x. Because I cut it in half, this side here is only x long instead of 2x long. So there's our first relationship. That one's twice as big. Now this one here we can prove using the Pythagorean theorem. Remember a squared plus b squared equals c squared. Plug in what we know. I know one of my legs is x, I know one of my legs is y, and I know my hypotenuse is 2x. So I can't simplify this side here, but I'll get 4x squared over here. Now if I subtract x squared, trying to get y squared alone, because that's what I want to know, I get 3x squared. And then just like the last proof, take the square root of both sides. And you can quickly see that this just becomes y. This becomes the square root of 3 times the square root of x squared. And since the square root of x squared simplifies, we get x root 3 one more time. So that means this y is x times the square root of 3. And this happens for every 30, 60, 90 triangle. So basically, you need to memorize this theorem and this theorem. You need to know those relationships. So let's do an example of this one. Find the values of x and y, give your answer in simplest radical form. So they tell me that this is a 30, 60, 90 triangle. That's all I need to know. I always find my short side first. So my short side here is related to my hypotenuse. Remember, this is 2 times the short side. So if it's 22, that means my short side has to be cut in half, or 11. And then remember, your long leg is whatever your short side is times the square root of 3. So that side is 11 root 3. Same kind of thing for this one, except they give you the long leg. So now remember, the long leg to the short leg, you need to divide by the square root of 3. So that means x is 15 divided by the square root of 3. You're going to rationalize the denominator. So you end up with 15 root 3 over 3. So that's what x is. And then, once you know the short side, all you got to do is multiply it by 2 to get your long side. So I'm going to do this 15 root 3 over 3 times 2. And that will give me 30 root 3 over 3. And because those can simplify, I really just get 10 root 3. So some of them are going to be a little easier, like A, some of them a little harder, like B, but you need to have those theorems memorized. So you should be able to justify and apply properties of both of our special types of right triangles. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.